Prove that root 3 plus root 5 is irrational. So let us assume root 3 plus root 5 is rational. Okay. Rational in the sense a rational number will be in the form of p by q, right? So therefore we can write it as root 3 plus root 5 is equals to p by q. In the bracket you can write p comma q are co-primes. Okay. Now in these two, let us transpose one of them to the other side. Let us transpose root 3 to the other side. So we can write root 5 is equals to p by q minus root 3. Root 3 is transposed to this side. Now squaring on both sides. So we can have root 5 whole square is equals to p by q minus root 3 whole square. Here square and root getting cancelled. So 5 is equals to, this is in the form of a minus b whole square. So here you can write here a minus b whole square is equals to, the formula is a square plus b square plus 2ab. Okay, using this formula we are going to split it into this form. What is our a value here? P by q. So p by q whole square plus b. What is b value here? Root 3 whole square minus, sorry, here it should be minus. So 2p by q into root 3. Okay. Next step, 5 is equals to, this square is for both numerator and denominator. So I can write it as p square by q square plus a square and root getting cancelled. So 3 minus 2p by q into root 3. Okay. Now let us bring this is an irrational part, this part. Okay, I am taking including the symbol minus. Okay, and this is all rational part. Okay, now here irrational part is having a negative symbol. Let us transpose this irrational part to the left side. So it becomes 2p by q root 3 is equals to, what are left here then? P square by q square plus 3, and this 5 will be transposed to this side, it becomes minus 5. Okay, now next step, 2p by q root 3 is equals to p square by q square, 3 minus 5 is minus 2. Okay, now here taking the LCM as a q square, we can write the numerator p square as it is because the denominator and here the LCM are same, minus multiply these two, so you get 2q square. Here it is 2p by q root 3. So here one q and in this one q getting cancelled. Let us keep only the irrational part here and bring this 2p to the other side. Here it is multiplying, comes to other side, divides. So root 3 is equals to p square minus 2q square by, we are having one q here, now we are bringing this 2p here, so it becomes 2p cube. Okay, now this is the LHS and this is the RHS. So here we can write that root 3 is irrational, and p square minus 2q square by 2pq is rational. Okay, we can say that therefore both never be equal. Both never be equal. Hence our assumption is false. Hence our assumption is false. Therefore, finally what you are right? Root 3 plus root 5 is irrational. Okay, this is how we can do the proof. So for this we need to practice. Okay, so when you practice, then it will be easier.